Hello and welcome to the first lecture on finance. In this lecture we are going to study time value of money. This is my wife's cat, Oscar. So if you happen to hear any meowing in the background, it is not me, it's him. So like I said, time value of money is probably the most important concept of finance, so pay attention. So I tell you that, will you give me $1 today and I will return it to you in a year's time? And you're going to say no, because from the dollar that you lend to me, you'd also expect to earn an interest. So money that you lend today, which is an investment, you expect a return. And that return is called the rate of interest. So if you lend me $1 and let's say you expect $1.05 back, which I agree to give to you, then the 5 cents is interest. And the rate of interest is 5 cents divided by $1, which will be 5%. So the money which you get back will be the money which you lent, that is $1, multiplied by 1 plus R, where R is 5%, that is 0.05%, means per 100, so 5 divided by 100 is 0.05, and that 5% is called the rate of interest. Now alternatively, you come and ask me for a loan and you promise to pay me back $1 a year from now. And the question is, how much would I be ready to lend to you today in exchange for this $1, which is not really here at the moment. It's going to be here in a year's time from now. So in exchange of this $1, which I'm going to get from a year from now, how much do I agree to lend to you today? And let's say the answer is, I say, okay, I'm going to give you 95 cents today for this $1 that you're going to give to me a year from now. And how did I come up on this number of 95 cents? Well, I have a discount rate for the money that I receive in the future. So the money that I receive in the future, I find the present value of it for me, that is how much I'm willing to give up today to receive that money in the future, and that present value is found by using the discount rate. So what I do is I say, okay, I'm going to get $1 back in the future, and if I have a discount rate of D, then I'm going to take this $1 and divide it by 1 plus D. So this D is going to be found by solving 95 cents, which is the present value today for me, which I'm ready to give to you, in exchange for the $1 which I'm going to receive in the future is 1 plus D. Now, if it was so that you needed to understand only rate of interest, or you needed to understand only rate of discount, then your work would become half, right? You wouldn't have to understand both, you just have to understand one. So let's see if there is a way in which you just have to understand one of them. So what we do is we try to answer this question by thinking about the international currency market. Now you may be wondering, what does the international currency market have to do with lending money and borrowing money? And you're going to find out. So in the international currency market, traders can exchange one currency for another currency. For example, they can exchange dollars for euros. So the exchange rate for dollar to euro is 0.80, which means that if you are sending money from the US to Germany, let's say, and if you have $100, then you are going to multiply that by 0.80 to get 80 euros. So the exchange rate from US to Germany is 0.80, which is the number by which you multiply the amount of dollars to get the amount of euros in Germany. Now the question is, what is the exchange rate from Germany to US? And the point is that it must be equal to the reciprocal of this exchange rate. So it must be 1 divided by 0.80 or equal to 1.25. Now, why is it that this must be so? It is because of something called arbitrage. The idea is that in financial markets, traders cannot earn a positive profit for sure without any risk. So that is called an absence of arbitrage. If you cannot earn a positive profit without taking on some risk. Now, how does arbitrage work here? Well, suppose instead of being 1.25, the exchange rate from Germany to US was 2. Then what would happen? How would traders exploit that? Well, what they would do is, let's say German trader has 100 euros, uses the exchange rate to send it from Germany to US. If the exchange rate is 2, then 100 euros becomes $200 in the US, and then brings it back to Germany, and if the exchange rate is 0.80, then $200 becomes 0.80 multiplied by 200, which is 160 euros. So the German trader started with 100 euros, sent his money on this round trip, and ended up with 160 euros. A predictable positive profit without any risk. Now that cannot happen in real life, unfortunately. So in real life, you have in financial markets what is called lack of arbitrage. You cannot make such profits. Therefore, it is necessary that the exchange rate from Germany to US is the reciprocal of the exchange rate from US to Germany, so it must be 1.25. Now, how does that relate to the rate of return and rate of discount? Well, what you should understand is that investing money is like sending money from the present to the future, just like you can send money from US to Germany, and borrowing money is like getting money from the future to today. When you borrow money, you get some money today, but then you have to pay that money in the future. So you have minus money in the future, but you have plus money today. Just like if you send money from Germany to US, you have minus money in Germany and plus money in the US. So by the same logic, the exchange rate from today to 1 year in the future, if that is 1.05, which corresponds to a 5% rate of return, then the exchange rate from the future to today must equal the reciprocal of this, that is 1 divided by 1.05. And what is this number that we have here, which is 1 divided by 1.05? So what is 1.05? This is the discount factor, right? When you bring money from the future to today, you divide by 1 plus the discount. So here, what you have is that the discount factor is 1.05. Therefore, the rate of discount must also be 5%. So which is that the rate of interest and the rate of discount must be the same. When you move on to, let's say, level 2, and you have things like FRA and derivatives, you will find that this is probably the most useful concept you can have. This will help you understand problems. This will help you understand what is going on. This idea that moving money across time is really no different than moving money across countries. Compound interest is when interest itself earns interest. And that is logical because interest is money. So there is no reason why money going forward should not earn more interest. The alternative to compound interest is simple interest. And I doubt very much you're ever going to come across simple interest in the real world. In the real world, people are real. They want real money for the investments that they make. So you should always assume that the interest rate which is being mentioned is a compound rate unless it is specifically mentioned that it is simple. So the question now is, if you have a principal P invested at an interest rate R for n periods, then how much money will you have at the end of those n periods? And the answer is P into 1 plus R to the power n. Now how does this happen? Well, you have the money starting with P, moving forward one period, then one more period, then one more period. Okay. And in the first period, when you move forward, the P becomes P into 1 plus R. So you start with one period, you move forward by a period, and now you have P into 1 plus R. Now this P into 1 plus R becomes the starting point for the next period. And in the next period again, it is going to grow by 1 plus R. So at the end of the second period, you're going to have P into 1 plus R into 1 plus R. And after n periods, you're going to have P into 1 plus R n times, or P into 1 plus R raised to the power n. So every period, your money is growing by a factor of 1 plus R. And so on, and after n periods, there are 1 plus R such factors, which is making your initial investment grow. So the total factor by which your investment grows is 1 plus R to the power n, and your initial investment was P, so the total amount of money you would have would be P into 1 plus R to the power n. Similarly for discounting, you are suppose paid $1 n periods from now. So now, instead of moving forward by n periods, you are now moving back by n periods. And each time you move back by a period, you're supposed to discount by the factor 1 plus R, or also known as 1 plus D, where D is the discount rate, which is also the rate of return or interest rate. So when you move back n periods, and each period you are discounting by the factor 1 plus R, then the amount that you have today for that dollar which you got n periods in the future would be that $1 divided by 1 plus R to the power n. So this is the factor by which the money that you would receive n periods from now this is the factor by which you would divide that money. Alternatively, if you had $X n periods in the future and your rate of discount was R, also you can say it was D. We just understood that rate of discount and rate of return are the same thing. So if you were to get $X n periods in the future, today the value of that to you, by which I mean what you would be ready to exchange for that $X you would get n period in the future, what you'd be ready to give up today, would be $X divided by 1 plus R to the power n. Now note, this 1 plus R to the power n, this factor by which you're dividing, is the reciprocal of this factor 1 plus R to the power n. So here it is multiplied by 1 plus R to the power n, here it is divided by 1 plus R to the power n. And this is consistent with the idea that the money that you're moving across time is the same as money that you're moving across countries. So here, instead of 1 period, you're now moving it forward n periods. So the factor by which you multiply to move it forward n periods is the same as the factor by which you divide when you move it back n periods. So what you're learning is that there is one exchange rate when you move money across time, whether it be 1 period or n periods.